There are a couple of database techniques that are really important for guaranteeing security. One of those is the creation of views. Views are important because a view can hide certain columns that might contain proprietary or sensitive data. The other technique is the use of database procedures. Database procedures can encapsulate the code for changing information, updating information. It can serve as a hedge against SQL injection techniques, and it can also guarantee that the logic and the control of the insert, update, and delete statements is maintained inside your code, which of course should be secured. So let's look into both these techniques now.
So here is an example of using a view for security. In this case, we're going to take a table like the students table, and notice that this table has some information that should not be made publicly available. The student's social security number should not be available to most people, nor should the banner ID, which gets access to certain systems, nor should the gender, and actually nor should the GPA. So what we can do is we can make a view and just eliminate those columns, as you can see below. We make a view called student view, we select the columns of interest, and then now people can work against the student view. So I would expose the student view to the entire population of the university so they can see the non-confidential information about students, and they will never know that the other fields exist. So then we can work at the view level and grant access on the view to a user, such as granting select to user Adam. Now Adam will only be able to see the fields that are publicly available. You can also extend this technique to update, insert, and delete. You can grant access on who can update or insert information, but when they work against the view, it's as if those confidential columns are never there. So they never get to see them, nor do they get to insert or update any information about them. It's like when we use views for security, it's like the rest of the world thinks it's a smaller table than it really is. Sometimes you need individuals to work with confidential data, but they can't associate it with an individual person. Such is the case in this example. In this example, we create a procedure called student statistics, and you can pass a column in as a variable. This procedure will then build an SQL statement, prepare it, execute it, and end. So if you call to this procedure, as you can see at the bottom, where you can call student statistics and pass it gender, you'll see the table that you see on the slide. Notice that the table does utilize the columns of gender and GPA because it's important to make sure that students of a certain gender are all being fairly graded, and this could be one way to look at that population. So while I'm able to see gender and while I'm able to see GPA information, it's never associated with an individual student. This is allowing a procedure to grant access to a confidential column in an aggregate form because we're doing some counts and some averages. Then, once you have such a procedure, you can grant execute on that procedure to somebody like Adam, who only has select abilities of the view, but now he can run this procedure and he can get the reports that he needs to do his analysis on students while preserving the confidentiality of that information. Here is a similar procedure, only this one takes in 2 columns and lets you do aggregate statistics for 2 different fields, such as gender and whether or not you are a transfer student. But you need to be careful. Even though these procedures do improve the security of confidential fields, you have to be careful of something called an inference attack, and you'll see that later in the lesson. If you're not careful, people can use such procedures to make inferences about the users and maybe try to deduce some of the confidential information. But in general, when you have a procedure that gives controlled access, it's always a better thing than letting users have uncontrolled access. Here is one more example of using a procedure to control, insert, update, and delete privileges. So in this particular case, we have a database user and schema called Scheduler. Scheduler is the account that is the owner of all the information. It's where all the tables are stored. So naturally, the scheduler, as a user, has full select, update, insert, and delete rights. But we can make a procedure as the scheduler, and we can use that procedure to build an insert statement. And what you see here is a typical procedure, except that it uses the keyword definer, and the definer is the person who's creating the procedure. So the procedure is called insert students. It takes in an ID, a first name and a last name, and it will then insert those values into the student table. Now, as I said, this is a very simple procedure. You could have more controlled checks on the information, so you could guarantee the integrity of the database. But the idea here is that you would use the procedure to do your inserts. So some unprivileged user would have access to this procedure, but they would not have access to the insert command for this table. That's going to force all the inserts to come through this procedure. And you can see at the bottom where we grant execute on the procedure to an unprivileged user. So even though an unprivileged user might only be able to select, they might be able to run this procedure, which will allow them to do controlled inserts. So this is a way to become very granular with your permissions, where you can allow them to insert or update or delete, but only through a controlled procedure. This reminds me of Java, where Java has its typical getters and setters. Rather than allowing users to access or set the value of an instance variable, you force the user to use a getter or a setter. And you can write code in the getter and setters in Java to make sure that people are using these fields correctly. And this is an analog to that. By using these procedures to control the insert, update, and delete access, you have total control of the command. The users can't just blindly insert. They would insert using your procedure, and your procedure may be able to offer additional security and integrity checks.